Welcome to This Is My Architecture. I'm Matt from AWS. Today we're at reInvent, and I'm really excited to be with Chang from Bristol-Myers Squibb. Thanks for joining.
Thank you.
So tell us about Bristol-Myers Squibb and what you do.
So Bristol-Myers Squibb is a large biopharma company. We're very active in the Amazon space, and I was here since the beginning with the team to help innovate and move culture change into the company.
Yeah, I remember I've been with AWS almost 6.5 years now, and I remember years ago going to see you guys. You've been doing the AWS thing for a long time, so thank you for that, and I'm sure you've learned a lot along the way.
Correct.
So today, it looks like from the icons on the board, we're going to talk about DevOps. Is that right?
Correct. So one of our key components that we have is called Auto-PTP, stands for Automatic Promote to Production.
Yeah.
It's the key service in our DevOps infrastructure, and that's what we're going to talk about today.
So I guess before we dive into the details of your current architecture, what problem were you trying to solve with Auto-PTP?
Right, so previously we actually have a DevOps process that most companies, we started with Jenkins and built a service on top of that. One of the problems that we're trying to solve is infrastructure as code. Once you move to Amazon, you really need to instill that in their culture. So it's not just application code, it's everything. And trying to do that with Jenkins, we found that there are some limits that we can't get into. So when Amazon released all these services, we jumped on top of it and start moving everything to that.
Got it. To give the viewers an idea maybe of scale, so the type of problem, like how many deployments or what kind of number can you give us to give us an idea of the scale of your DevOps?
Right, this has been in production for several years now, and we're very happy that this year we actually broke 100,000 deployments on this infrastructure. 100,000
deployments in 1 year?
Yes, the year's not over yet.
Yeah, you're right. That's amazing, because I work with some customers that are struggling to get beyond one deployment a quarter, so 100,000. So that's great. So at that scale, I imagine when you were using Jenkins before, that in and of itself is an operational problem.
Correct.
Is that right?
You end up with what is known as a farm of Jenkins, and then you end up managing Jenkins more than you're managing your DevOps innovation, and it's really not worth it. With Amazon, especially things like code build, we pay as you go. We can actually have nothing running on the weekend since nobody's building, and on a Monday you could have 100 deployments at the same time. So it actually scales up and down. It's very, very beneficial for us to be on this kind of platform.
That's interesting, because a lot of people think about elasticity in terms of like web traffic, but you're talking like deployments. So if you have 1,000 deployments on a Monday, code build, code pipeline to scale up for that. 0 on a Sunday, you don't have to pay for that.
And just before the holidays, we suddenly go like crazy, and nobody has to suddenly worry, I don't have enough Jenkins servers.
Okay.
So.
Well, that's interesting, and it's cool that you're making that transition. So let's dig into the architecture a little more. So I see, you have some JSON over there. How does it work? How does the user use this?
So the user usually approach this with already some kind of code they want to deploy.
And can that be any language? Or?
Can be any language. It's infrastructure as code as well as the actual code. So
both the infrastructure and the code itself.
Right. You can have CloudFormation. You can have the Beanstalk with Java, Node.js, anything else. So you come with something to deploy. We even provide an initial package just to try this called the null deployment. So you just come with a single CloudFormation that does nothing.
Okay.
You provide something called a deployment descriptor, which is a simplified JSON.
So why aren't you using like CloudFormation for that piece?
Yeah, because the full stack of service actually have a lot of details in it that we don't want to bother the user with.
Okay.
And so we actually really simplify to what the user bare minimum should need to know.
And what is that? What is that bare minimum?
There'll be things like, I want to deploy from this from this source repository. This is my stack name, and here are my code. Without even getting into detail, we have integration with like ServiceNow.
For change management.
Change management. We have notifications that we tell them. We figure out how to copy source code from place to place. So all that detail they don't have to worry about, and they just tell the minimum. So with that deployment descriptor submitted to an API gateway, we are able to construct code pipeline on the fly. So this is really another way of looking at it, is a code pipeline factory.
And so rather than have like a giant YAML file or a giant JSON, you have just the basics. And I imagine it's also an opportunity to introduce some of your standards for your corporate standards.
So it also means that when we introduce new standard, we just change this factory, and everyone suddenly gets it. So it's a single point of control, governance.
So how does the factory actually work? I mean, I understand, you maybe use curl or something to hit API gateway, it triggers a Lambda and kicks it off. But let's get into a little more detail. So once you send in that JSON file, what happens?
Right, so you will take the JSON file and submit it either through curl or we have a website to do that.
Okay.
You browse and submit. The Lambda will actually read what you're trying to do because it could be multiple tasks. You could be deploying a single CloudFormation, 5 CloudFormation, one after the other, or in parallel, or source code. So it reads what you're trying to do and build the code pipeline for you.
Okay.
ServiceNow will come in if you're trying to do more than dev and UAT. We need an approved ticket, so they'll actually go out and check to make sure you have the ticket, the change request ticket approved.
So in this piece with the change request, there might be a manual approval in some cases, I imagine. How do you coordinate the steps? If you have to wait for an approval, are you using like lambdas for that or step functions? How does it know when to execute the different steps and when to wait and restart again?
Right, so we have a combination of lambda, step function, and what is known in Copilot as manual approval steps.
Okay.
So these 3 work together to make sure that you have something in ServiceNow.
Yeah.
And when it's approved, it comes back and then automatically
and CoPipeline can coordinate that.
Coordinate it. So all that is built in. Again, the user don't have to worry about that. They just say what I'm trying to deploy.
It's a good example of the complexity that you don't ask them.
Exactly. Yeah. So basically, once you kick off this factory and it runs the code pipeline, all the source code alignment is done for you. Number of tasks that you want is figured out for you, and the CloudFormation or the source code build will then happen. One of the things we also do that's not shown here is integration with CICD.
Okay.
So you run the code the first time, but once it's established, it actually watches change folders and from the source.
So once this pipeline is up, if I push new code, it'll redeploy it automatically, or deploy the new changes automatically.
Correct, and it's at the master and task level. So if you change your master CloudFormation, it will obviously run again. But if you just change module A, it will just build module A, and everything is all in parallel.
Where is this code getting pushed? Are you prescriptive about what code repositories the users have to use?
We have some flexibility there. We use S3 Subversion. We also have some code commit.
Code commit, yeah.
Right, so essentially the user can actually specify a few different ways.
Okay.
And we handle how to go there and how to fetch the files and how to coordinate.
So this part here, what does this task mean?
So the reason is a lot of times you might want to build multiple CloudFormation. You might want to actually compile in different steps.
Sure.
So this task actually shows up as like job descriptions in the deployment.
Got it.
And we handle how you actually build that. If you actually had to do all this code pipeline vanilla, it's a lot of work.
Yeah.
Whereas if you simplify with the deployment statement, it's really, really small. And we handle everything down to sub code pipeline. So
because I was going to ask you that you have another code pipeline. So what does the second one down here represent?
So it means bring your own pipeline. So some team wants to do additional work. They want to do automation tests. They want to do performance tests or a special kind of build. They can actually invoke their sub pipeline.
So this is sort of a master pipeline, and within that, you can have custom sub pipelines that users bring. Yeah. Interesting. Okay.
Yes. And we also use code deploy, which allows us to put the code in, Beanstalk.
Sure.
But also, you can deploy to on-prem. So if you have the code deploy agent on any of your servers, it will just run the same Auto-PTP service would be able to reach into that.
Wow. Okay.
Yeah.
So one last question. Once users are successful and they build their pipeline and they're using CI/CD and new code is getting pushed, what happens next? Are there notifications? How do they know that it's working the way it's supposed to work?
Right, so one of the things is the Lambda and the step function that we have in here actually sends notification out whether it's successful or not. So the user will actually have the full detail of a successful, or it's actually more useful to know it's not successful and get all the errors.
Great.
So we send that as an email to the user.
Great. So yeah, you're giving visibility to your users, and yet abstracting away that are perhaps unnecessarily complex for them, so they don't have to deal with it. You're still maintaining flexibility in terms of code and code repository and a lot of sub-pipelines. It's really an interesting architecture that I think a lot of our enterprise viewers who really work at scale will find very interesting. So thanks for sharing it with us.
Thank you.
And thanks for watching. This is my architecture.